Securing layer 2 switches, topology. Between ALS1 and ALS2 of Ethernet 11 and 12, I will use gigabit 11 and 12. Between DLS1 and DLS2, same ports. Between Fast Ethernet 7 and 8, between DLS1 and ALS1, Fast Ethernet 7 and 8, same case between DLS2 and ALS2, 7 and 8. I will use gigabit 01 and 02. Between DLS1 and ALS2, 9 and 10, same case between DLS2 and ALS1. I will use gigabit 03 and 10. The connection to all computers using Fast Ethernet 6 on DLS1, on ALS1, and on ALS2. I will use gigabit 13. Build initial configurations to create usernames and passwords on the Linux containers on the computers. No. And launch simulation. Yes. required resources on a real lab, and configure the basic switch parameters and trunking. Okay, but first of all, erase the contents on all the devices. These are the commands to remove all contents from the switches. Delete the environ file, place it on flash 0, and delete the ios config.txt file, place it on flash 3. Then reload the device. These blank lines are used to simulate the enter key. But remember that for real switches, for example, layer 3 switch, this is the script to remove all contents, and these are the commands. And for a layer 2 switch, this is the script, and these are the commands. I will use this only for VIRL. DLS1, enter. Enable. Password by default Cisco, and paste. DLS2, enter. Enable. Cisco, paste. ILS1, enter. Enable. Cisco, paste. ILS2, enter. Enable. Cisco, paste. Go to DLS1 and wait a moment. Configure hostname, password, and telnet access on all 4 switches. Okay, hostname and password for console. Login to enable the password on line BTY 0215. Password Cisco. Login, and also you can set the enable secret password to class, for example, apply this on all switches. Enter. Enable configure terminal, paste. Hostname DLS1, DLS2, enter. Enable configure terminal, paste. DLS2, ALS1, enter. Enable configure terminal, paste. ALS1, ALS2, then paste. Hostname ALS2. So configure management IP address on VLAN 99. Okay, choose 3 and 4 because 172.16.89.1 will be the virtual default gateway for VLAN 99. Use 3 and 4 for the IP addresses on DLS1 and DLS2. Okay, DLS1 interface VLAN 99 IP address 16.99.3 and subnet mask 24. Okay, this command 172.16.99.3.24. Shut down and go to DLS2 interface VLAN 99 IP address 4. Okay, this command no shut down ready. Configure the default gateway on the access layer switches. The distribution layer switches are layer 3 devices and do not need default gateways. Configure AO2.1Q trunk between the switches according to the diagram. On the 2960 switches, only .1Q is supported, therefore the switch port trunk encapsulation command is unavailable. As an added security measure, change the native VLAN on the trunks to VLAN 666, a VLAN designated only for native VLAN traffic. The command to change the native VLAN is switch port trunk native VLAN 666. Also turn off switch port negotiation on the port using switch port negotiate command. Well, and this is the example for DLS1. I just configured the hostname, passwords, and the interface VLAN 99. So configure the trunking ports, okay, from 7 to 12. Okay, 6 ports, the trunking ports. Okay, go to DLS1, enter, exit, interface range. In my case, the trunking ports are 1 and 2, 01, 02, 03, 10, 11, and 12. Gigabit 01 to 3 and gigabit 10 to 12. 6 ports. Okay, switch port trunk encapsulation .1Q, switch port mode trunk, switch port trunk native VLAN 666, switch port no negotiate. Okay, same process on DLS2. Exit interface range gigabit 01. Okay, the same commands on all the switches. Okay, these commands on DLS2, the same ports, paste, ready. Okay, this is the example for ALS1. I just configured the hostname and passwords, configure interface VLAN 99 with the IP address 101 and default gateway 1. Then apply the configuration for trunking ports. Okay, go to ALS1, enter, interface VLAN 99, IP address 172.16.99.101, subnet mask 24. Okay, this command, no, shutdown, exit, IP, default, gateway. Okay, that command then apply the configuration for the trunking ports, enter and paste. And for ALS2, VLAN 99, 102, default gateway, and trunking ports. ALS2, enter, interface VLAN 99, IP address 172.16.99, 102, 24, no shutdown, exit, IP default, gateway 172.16.99.1. Okay, this command, the interface VLAN 99, the IP address 102, no shutdown, default gateway, and then enter and then apply the trunking ports configuration. Ready. Okay. Very nice. Enter. Enter. Now continue with the verify trunking and spanning tree operations using the show interfaces trunk and show spanning tree commands. Which switch is the root bridge? For example, go to ALS1 and show interfaces trunk space, then very well configured VLAN native 666 and trunking encapsulation 1Q mode on, and show spanning tree. Okay, on ALS1 you can see gigabit 00, and this is part of BIRR system. For example, on ALS1, double click here and you can see all the ports, but gigabit 00 is not present. Okay, this will happen only on BIRL, but I will disable gigabit 00. I will shut down this interface. I recommend to do this in all devices. Interface gigabit 00 shut down. DLS1, Cisco enable class configure terminal, paste. Okay, gigabit 00 shut down, DLS2, Cisco enable class configure terminal, paste. ALS1, and Cisco enable class configure terminal paste ALS2, enter Cisco enable class configure terminal paste. Okay, gigabit 00 administratively down. And now go to ALS1, enter, and show spanning tree. And look at this. The local bridge ID is 4002 and the root is 4000. If you go to DLS1, enter and show a spanning tree. Local bridge ID 4000 and the root is 4000. So DLS1 is the root bridge. Okay, DLS1 the root bridge. But go to ALS1. For ALS1, which trunks have the role of designated alternate and root. Designated gigabit 11, 12, and 13. Gigabit 11, 12, and 13. One, two, and 13. The alternate 03 and 10. 03, sorry, 02, 03 and 10. 02, 03 and 10. Zero 1, 02, and 10. 01, 02, and 02, 03, and 10. 02, 03, and 10. 02, 03, and 10. Finally, the root is only one port, gigabit 01. Okay, 01. This. Okay, on ALS1, gigabit 01 is the root port because it's facing the ALS1. That is very nice. On ALS2, go to LAS2 and show a spanning tree. Okay, and designated gigabit 13. Only gigabit 13, and is this. Okay, this interface connected to the computer. Alternate 01, 02, 10, 11, and 12. 01, 02, 10, 11, and 12. Zero one, 02, 10, 11, and 12. Alternating ports. And finally, the root is gigabit 03. This interface gigabit 03. And obviously, because it's the port connected to DLS1 that is the root bridge. Also, on DLS2, you can review that and under show spanning tree space designated ports gigabit 01, 02, 03, and 10, and gigabit 13. Okay, 01, 02, 03, 10. Okay. On DLS2, designated ports gigabit 01, 02, 03, and 10. 01, 02, 03, and 10. The alternating port is 12, is this, and the root gigabit 11, this. Okay, gigabit 11 is the port connected to DLS1 that is the root bridge. Finally, review on DLS1, show spanning tree. Because DLS1 is the root bridge, all ports are designated ports. 01, 02, 03, 10, 11, 12, and 13. Okay, gigabit 01 designated 02, designated 03, 10 designated 11, 12 designated, and 13. Okay. A strong negotiation being used here. Which more are the trunks in? Okay, for example, on DLS1, Cisco enable class show interface trunk. And look at this. Gigabit 01, 02, and 03 gigabit 10, 12, and 13. Mode on. Status trunking, and the encapsulation AO2.1Q. Now, trunks are statically set to AO2.1Q trunks. Configure VTP on ALS1 and ALS2. Set up the VLANs according to the diagram. This diagram, VLAN 99, 100, 150, and 200. On networks 99, 100, 150, and 200. Two VLANs are in use at this time, one for subnet students and one for faculty and staff. These VLANs will be created on DLS1, which is set up as a VTP server. DLS2 also remains in its default VTP mode and acts as a server as well. ALS1 and ALS2 are configured as VTP clients. The user access ports for these VLANs also need to be configured on ALS1 and ALS2. Set up this port as a static access ports and activate spanning tree port fast. Configure these ports according to the diagram. This is the example for ALS1, VTP mode client, and the range of interfaces, access and access VLAN 100 and port fast. Same case for ALS2, mode client, interface range. Go to ALS1 and I will configure 1.3 that is connected to the PC, and I will use the range from 2 and 2.3 to also configure on VLAN 100. Okay, first of all, configure terminal VTP mode client, on ALS1, enter Cisco enable class, configure terminal, interface, range, gigabit 1.3, and gigabit 2.2 and 2.3. Okay. Gigabit 1.3 and 2.2 and 2.3. And switch port mode access. Switch port access VLAN 100. Spanning tree for fast. Port fast. Exit and don't forget to configure VTP mode client. Go to ALS2, Cisco enable class, configure terminal, interface range, gigabit 1.3, 1.3, and gigabit 2.2 and 2.3. Switch port mode access, access to, in this case, VLAN 200. Okay, VLAN 200. Okay, this VLAN. 200. Spanning tree port fast. Okay, exit VTP mode client. That is very well configured. Configure IP routing, the VLAN switch virtual interfaces, and HSRP on DLS1 and DLS2. HSRP is a requirement for the network, and VLANs 100 and 200 are configured to use HSRP to provide redundancy at layer 3. Use the priority command to make DLS1 the active router for VLANs 1 and 100 and DLS2 the activate router for VLAN 200. This is the example for DLS1. Configure the domain, the version. Don't forget that the DLS1 VTP mode by default is server. The VLAN 99, 100, 200, 666, and 999. Finally, enable the IP routing. Okay, DLS1 VTP domain switch POD VTP version 2 VLAN 99. The name is management. VLAN 100. The name is staff. VLAN 200. The name is student. VLAN 666. The name is native. VLAN do not use. And VLAN 999. Name parking lot. Exit and enable IP routing. Now configure the switch virtual interfaces, SVIs, and HSRP on DLS1. 99 with the IP address, the virtual IP address 99.1 preamp priority, 100 100.3 virtual IP .1 preamp priority. But for VLAN 200, the IP address, the virtual IP, but only preempt. Do not configure priority here. Okay, DLS1. Interface VLAN 99. Standby. Group 99 IP 72.16.99.1. Preempt. Priority 150. No shutdown. VLAN 100. VLAN 100. The IP, okay, IP address 172.16.100.3. Subnet mask 24. The virtual IP 100.1. Group 100. Don't forget that. The preemption 100 group. And priority 100 group, priority 150. Now shut down. Okay, and now configure 200. Interface VLAN 200. The interface VLAN 200, the IP address 200.3. Okay, 200.3, and the virtual IP group 200, the virtual IP 200.1. And preempt 200 group preempts. Do not configure priority here and not shut down. On DLS2, do not configure the VLANs, only configure the switch virtual interfaces and HSRP. Enable the IP routing interface VLAN 99 with the virtual IP preempt VLAN 100, IP address, virtual IP preempt interface VLAN 200, IP address, virtual IP preempt, and priority here. Okay. DLS2, enter. Cisco enable class configure terminal. Enable IP routing interface VLAN 99. The IP is already configured, so configure HSRP standby group 99, the virtual IP 99.1, preemption no shutdown, and configure VLAN 100, configure the IP address 172.16.100.4, subnet mask 24, the virtual IP 100.1, group 100. Don't forget that. Preempt on group 100 and not shut down. Don't forget to enable these interfaces. And VLAN 200 the IP address, okay, VLAN 200, the IP address 200.4, enter group 200, virtual IP 200.1, the preemption group 200, but here configure priority on group 200, priority 150. And finally, enable the interface with the not shutdown commands. Enter, very nice. Verify your configurations using show VLAN brief, show VTP status, show standby brief, show IP route. For example, on DLS1 and show VLAN brief, show VLAN brief. Okay, all the VLANs 99, 100, 200, 666, 999. Show VTP status. Domain name version 2. The mode server. Show standby brief. Okay. VLAN 99, group 99, priority 150. The state is active. The virtual IP 1, the local IP 4. Also active for VLAN 100, but for 200 is only a standby. Show IP routes. 3 directly connected networks. How many VLANs are active in the VTP domain? Okay, and the active VLANs are 1, 2, 3, 4, 5, 6. But also, all these VLANs here are considered active. Okay, for this active. So they are 10 active VLANs, and 1, 2, 3, 4, and 5 built-in VLANs, and 1, 2, 3, 4, 5 new VLANs. Okay, 10 active VLANs. What is the active router for VLANs 1 and 100? What is the active router for VLAN 200? Okay, VLAN 1 is not configured with HSRP, so this should be 99. And the question is, what is the active router for VLANs 99 and 100, and what is the active router for VLAN 200? For 99 and 100, DLS1 is the active router, DLS1, but for VLAN 200 is DLS2. Okay, go to DLS2 and show standby brief. Okay, for 200, this is the active local router, DLS2. Okay, for VLAN 99 and 100, the active is DLS1. Also verify show VLAN brief. Okay, all VLANs 99, 100, 200, 666, 999. Show IP route. The directly connected networks 4 VLANs. So the directly connected networks 3 VLANs with IP addresses. 3 directly connected networks. Show VTP status. This is the version 2, domain name, mode server. What would be the effect on virtual interface VLAN 100 if VLAN 100 had not been created? The status of switch virtual interface VLAN 100 would be up, but the line protocol will be down. Also, the directly connected network 172.16.100.0 will be not present in the routing table. Configure spanning tree route switches. Configure DLS1 to be the primary route for VLANs 99 and 100 and secondary route for VLAN 200. Configure DLS2 to be the primary route for VLAN 200 and the secondary route for VLANs 99 and 100. DLS1 route primary for 99 and 100 and secondary for 200. DLS2 route primary for 200 and secondary for 99 and 100. DLS1 enter and Cisco enable class configure terminal and spanning tree VLAN 99 and 100 route primary and 200 route secondary. DLS2 enter Cisco enable class configure terminal spanning tree VLAN 99 and 100 route secondary and VLAN 200 route primary. Specify verification methods and mitigation techniques for attack types. Complete the following table with appropriate verification methods and mitigation approaches for the attack types specified in the left column. The attack type, MAC address spoofing or flooding. To verify, use the show MAC address command, and to mitigate, port security and DHCP snooping. For DHCP spoofing, to verify, view the DHCP lists for discrepancies, and for mitigation, configure DHCP snooping. and unauthorized LAN access. The verification is very difficult for this type of attack, but you can configure AAA, the authentication using AAA. Security implementation, storm prevention. When packets flood the local area network, a traffic storm occurs. This could degrade network performance. Storm control feature help to protect against such an attack. Storm control is typically implemented at the access layer switch port to mitigate the effects of a traffic storm before propagating the network. Storm control can also be implemented on trunk interfaces, including port channel interfaces, to protect distribution layer devices from traffic saturation, which could have a much broader impact on the network. Storm control can detect and mitigate storms of broadcast, unicast, or multicast traffic. As a part of the configuration, you must specify what qualifies as a storm. Either a rising and falling threshold based on the percentage of an interface bandwidth used. The storm is recognized when X percentage of the interface bandwidth is used and seen to be evaded when Y percentage of the interface bandwidth is used, or based on rising and falling threshold measured in either bits per second or packets per second. This is the command storm control. The options are unicast, broadcast, multicast, and this is the level. The rising threshold between 0 and 100, the falling threshold between 0 and 100. Bits per second on kilobits, megabits, or gigabits. The rising threshold. Failing threshold, packets per second, rising threshold, failing threshold. To accurately configure these levels, you must know the amount of these traffic types flowing your network during peak hours. When traffic storm is detected, a storm control is configured. The default response is to silently filter the traffic. Storm control can optionally be configured to either shut down the interface receiving the traffic storm or to send an SNMP trap to the NMS. Enable broadcast storm control on access ports. Enable storm control on fast Ethernet port 6 15 to 24 on ALS1 with the following parameters. Unicast storms will be noted at 65% bandwidth usage and abided at 35% bandwidth. Broadcast storms will be noted at 1000 packets per second and abided at 300 packets per second. Multicast storms will be noted at 40% bandwidth usage and abided at 25% bandwidth. If a storm is detected, send an SNMP trap. The range of interfaces, the unicast configuration, broadcast, multicast, then the action to send SNMP trap. Okay, on access switch ALS1, enter Cisco enable class configure terminal. Okay. In my case, the range of interfaces gigabit 13 and gigabit 22 and 23. interface range gigabit 1.3 and gigabit 2.2 and 2.3. Storm control for unicast, the label, use the mark question to see the option. Okay, is storm control, and mark question Okay, storm control is not supported by BIRL. Okay, exit. Okay, for example, only an individual, a single interface, for example, interface gigabit 1.3, mark question. No storm control. So it's not supported by BIRL. Okay, but if you configure storm control on unicast and set the label 65 and 35, okay, know that 65% of bandwidth and abided 35% bandwidth. In case of broadcast, the label you can set packets per second, 1000 packets per second to be noted, okay, at 1000 packets per second, and abided 300 packets per second. This 300 packets per second. And multicast 40% of bandwidth and 25% bandwidth to be abated. Okay. Know that 40% bandwidth and abated and 25% bandwidth. And if a storm is detected, send an SNMP trap. Use the show storm control command to verify. For example, FastEthernet 6, you can see the show storm control FastEthernet 6 unicast, broadcast, and multicast. Demonstrate the storm control operation. To demonstrate the effects of storm control, configure unicast storm control on DLS1 interfaces 7 and 8 with purposely low numbers and then generate traffic from ALS1 that will cause the threshold to be exceeded. On the interface range from 7 to 8, set the storm control for unicast, the level and bits per second to only 750 bits per second to note the storm, and 300 bits per second to abide it. And obviously these are very low numbers, and the action is shut down the interface, then exit. And remember this configuration on DLS1, and at ALS1 issue the command ping to DLS1 and repeat 1000 of times. Within a few seconds you will see a syslog message on DLS1 indicating that a storm had been detected and the interface is shut down. Okay, look at here. Error disabled, storm control error detected on FastEthernet 7, storm control shut down. The packet storm was detected interface has been disabled. Line protocol down, state down. Okay, the same process for FastEthernet 8. Reset the storm control configuration on DLS1, FastEthernet 7 and 8, and because these interfaces are not shut down due to error disabled, you have to manually reset them by issuing the shutdown and not shutdown commands. While you do this, remove the storm control from the interfaces. Okay, on DLS1, go to interface range 7 and 8, shut down the interfaces, remove the configurations for storm control, and then not shut down to enable interfaces. Configure port security. To protect against MAC flooding or spoofing attacks, configure port security on VLAN 100 and 200 access ports. Because the two VLANs serve different purposes, one for staff and one for students, configure the ports to meet the different requirements. The student VLAN must allow MAC addresses assigned to a port to change, because most of the students use laptops and move around within the network. Set up port security so that only one MAC address is allowed on a port at a given time. This type of configuration does not work on ports that need to service IP phones with PCs attached or PCs running virtual machines. In this case, there would be two allowed MAC addresses. To enable security on a port, you must first issue the switchport port security command by itself. The staff MAC address did not change often, because the staff uses desktop workstation provided by the IT department. In this case, you will configure a staff VLAN so that the MAC addresses learned on a port is added to the configuration on the switch as if the MAC address were configured using the switchport port security MAC address command. This feature, which is called sticky learning, is available on some switch platforms. It combines the features of dynamically learned and statically configured addresses. The staff ports also allow for a maximum of 2 MAC addresses to be dynamically learned per port. Okay, now configure the basic port security. On ALS2, by default, issuing the switchport port security command by itself sets the maximum number of MAC addresses to 1. The violation mode is shut down. It is not necessary to specify the maximum number of addresses unless it is greater than 1. Okay, go to ALS2 on FastEthernet 6 and 15 to 24, enable port security. Okay, go to ALS2, and in my case, gigabit 1.3 and gigabit 2.2 and 2.3. ALS2, enter, Cisco, enable, class, configure terminal, interface range, gigabit 1.3 and gigabit 2.2 and 2.3. Switch port security. Okay, done, and then verify. Show. Enter show port security on FastEthernet interface FastEthernet gigabit, for example, 1.3. And by default, port security enabled by default, violation mode shut down, maximum MAC addresses 1. Configure additional port security parameters. On ALS1, the interface range was Ethernet 6 and 15 to 24. For security, maximum of 2. And switch port security MAC address sticky. Okay, first enable port security with the switch port security command. Use the switch port security maximum to change the maximum number of MAC addresses to 2. And use the switch port security MAC address sticky command to allow the 2 dynamically learned addresses to be added to the running configuration. Okay, ALS1, enter. Cisco enable class configure terminal interface range gigabit 1.3 and gigabit 2.2 and 2.3. Switch port security maximum 2 MAC address sticky and show port security interface for Ethernet gigabit 1.3. In my case, is 1.3. Okay, violation shutdown 2 MAC addresses and sticky MAC addresses 0 for now, but you can generate traffic using a ping, and you will generate traffic, and sticky MAC addresses will be 1. Okay, and now configure the PCs. Okay, for example, VLAN host A, VLAN 100. Yes, Cisco IF config, configure Ethernet 1, sudo IF config Ethernet 1, the IP address. For example, on network 100.1, 100.1 is the default gateway, but you can use 100.10. Okay, password Cisco mask net mask 24. Verify the default gateway is this. Remove that sudo IP root. Remove default via. Okay. Oh, it's delete. Okay, delete. And add the new one. Add 101. Okay, then verify. Okay, very nice. Host B. Cisco sudo ifconfig Ethernet 1 200 that 10 Cisco the net mask 24 uh, remove this sudo ip root delete default via and add the new very nice. For example, go to host A, then host A, and ping the default gateway. Success. Control C to stop. Go to ALS1, then repeat the command, show port security interface gigabit 13, and the sticky MAC addresses learned 1. Okay, and go to host A and ifconfig. The MAC address for Ethernet 1 is this, FA163E7C1B25. And on ALS1, FA163E7C1B25. Okay. And last source address column and the VLAN. Last source address column and VLAN 100. Configure error disabled port automatic recovery. When some violation occurs on a port, the port will transition to an error disabled state. The only way to clear a port that has been error disabled is to perform a shutdown command and then a shutdown on the interface. This method, of course, requires manual intervention by an administrator. Error disabled ports can be configured to automatically recover from port security violations with the use of the error disabled recovery calls. An interval can be configured so that after a specified time, the port will automatically clear the violation. The command to verify the error disabled configuration is the show error disabled recovery. Configure the switch to automatically recover an error disabled port caused from port security violation. Notice there are many different options for which you can configure error disabled recovery. However, we will configure it only for port security violation. Error disabled recovery cause and mark question to be the options are all ARP inspection, PPDU ward, and other options, storm control, but this is the security violation or P security violation. Okay, this is port security violation. Okay. Okay, so use error disable recovery cause port security violation. Okay, and this configuration is placed on ALS1. Configure terminal and error disable recover cause. Mark question to be the options. And you have all the options including port security violation, port secure dash violation. Enter. Okay, and the interval 30, and that means 30 seconds. Okay, 30 seconds. If no recovery interval is specified, the recovery time defaults to 30 seconds. Okay, and set only to 30 seconds. Recovery interval to 30. And verify, show error disable recovery. And show error disable recovery. Okay, this command show error disable recovery. Okay, and port security violation enabled 30 seconds. Okay, go to host A and ping to default gateway, success, Control-C to stop. For example, on host A, you can change the MAC address, ifconfig, and change this MAC address. Okay, and use the following commands. First of all, shut down the interface, sudo ifconfig, Ethernet 1, down, Cisco. Okay, sudo ifconfig, Ethernet 1, hardware, ether, use the following, for example, 33, enter, then up the interface, sudo ifconfig Ethernet 1 up, and then verify again with the ifconfig command. And now you can see the new MAC address. Ping to DLS1, success, Control-C to stop, and go to ALS1 and repeat the show error, show port security interface gigabit 13. Now you can see the last source address is 33, VLAN 100, and total MAC addresses 2, sticky MAC addresses 2. And now I will change again on host A. Down the interface, set the new can be 44, the new hardware address, then up and verify. And it's this 44. Ping default gateway, and ping fails because ALS1 error disable port security violation. Repeat the port security command, secure shutdown. Okay, and wait 30 seconds. Okay, but go to host A and Control-C to stop the ping. You need to stop the ping, and from now you can count to 30 seconds. Okay, go to ALS1, enter, show port security interface gigabit 13, secure shutdown, and count 30 seconds. Attempting to recover for port security violation, up, protocol up, enter and repeat the command, and last source address 0, okay, VLAN, no VLAN, sticky MAC addresses 2, okay, security violation count now 2, with the port status is secure up. Go to host A and ping the default gateway. Control C to stop. IF config, destination host unreachable IF config. Okay, I have this MAC address 44. Ping the default gateway. Destination host unreachable. Control C to stop. Go to ALS1. Security violation occurred. Enter. Okay. Stop the ping and then count 30 seconds. Attempting to recover, change state to up, protocol up. Enter and show port security secure up. Okay, is up. But now go to host A and change to the previous original MAC address. Down the interface, change the MAC address to the original 25. Up the interface, then verify. Okay, now try to ping the default gateway. Success. Control C to stop. Go to ALS1, port security, gigabit, interface gigabit 1.3, secure up. Okay, show port security, interface gigabit 1.3, secure up. Maximum MAC addresses 2, sticky MAC addresses 2. Violation count 4, last source address and VLAN, this 25 and 100. Very nice. Configure IPv4 DHCP snooping. A DHCP spoofing is a type of attack primarily where an unauthorized device assigns IP addressing and configuration information to hosts on the network. IPv4 DHCP servers reply the DHCP discover frames. These frames are generally broadcast, which means that they are seen all over the network. The attacker replies a DHCP request claiming to have valid gateway and DNS information. A valid DHCP server may also reply to the request, but if the attacker's reply reaches the requester first, the invalid information from the attacker is used. This can lead to a denial of service or traffic interception. Observe DHCP behavior before applying DHCP snooping. To validate this is happening, observe the current operation. On ALS1, reassign host A fast Ethernet 6 from VLAN 100 to 200 and run Wireshark on host A. Fast Ethernet 6, in my case gigabit 1.3, switch port access VLAN 200. Go to ALS1. Enter Cisco enable class and configure terminal interface gigabit 1.3 switch port access VLAN 200. Change host host B network configuration from a statically assigned address on VLAN 200 to use DHCP. On Windows, use ipconfig/renew on host B. Okay, use the ipconfig renew option to request IP address. Go back to host A where Wireshark is running. Host 8's Wireshark session will capture the DHCP discover frame from host B. Okay, host A now is in VLAN 200, so now host 8 is host A is now placed on VLAN 200, and host B also placed on VLAN 200. Go to host B and ifconfig to verify the IP address 172.16.210. With host A, ifconfig 172.16.110. I will configure 211 because host A is now placed on VLAN 200. (211), for example, Cisco netmask delete the default gateway 101. Okay, IP root. Okay, not default via. So you can configure at the default via to 200.1. Okay, ifconfig. Okay, host A 211, IP root, default via 201, host B, ifconfig 210, default via show IP root on IP root, default via 201. Okay, but this is host B. This is host A. On host A, run Wireshark. Okay, host A. I will use TCP dump. Okay, sudo TCP dump interface Ethernet 1. Enter. Okay, these are HSRP detected. But on host B, go to host B and configure dynamic configuration for IP addresses. Configure DHCP client. On Windows, use the ipconfig renew command. Okay. On Linux, use the following command. Okay. Sudo DHC client on Ethernet 1. Enter. Cisco. Go to host A to look at the DHCP. Okay, and go to host A, DHCP request from this MAC address. Okay, I think that is enough. Control C to stop the process from TCP dump and go to host B. And it's still trying to get an IP address from a DHCP server. My DHCP server is PCC, but it's not configured as DHCP server, so it's not finding a DHCP server. Don't worry, look at here. On Windows and graphical user interface, you can see the bootstrap protocol request. Okay, and on host A, you will see something like this. Okay, no IP because the host B still does not have an IP. Okay, the port is boot PC. Okay, and this is the source. Host B does not have an IP address. This is the port. Boot PC. Okay, and finally host B, AAA Config, and the static IP address remains the static IP address. Okay, okay, on host B, but on host A, look at here, the source IP there is no source IP because host B does not have an IP for DHCP. Boot PC means boot port client. That's UDP port 68, and the destination is it's a broadcast. All PCs boot PS is port for the server, that is 67. It's a boot for DHCP. A request from this MAC address 8D0. Okay, go to host B and verify. Okay, 88D0. So this is the source. This MAC address, host B. Host B is the source. The length 300. Okay. Okay, and host B was trying again and again to get an IP address from a DHCP server. Okay, and if a host A were an attacker, the attacker could craft DHCP server offer messages or other DHCP server messages to respond to host B's DHCP request. To help protect the network from such an attack, you can use DHCP snooping. DHCP snooping is a Cisco Catalyst feature that determines which switch ports are allowed to respond to DHCP requests. Ports are identified as trusted or untrusted. Trusted ports permit all DHCP messages, while untrusted ports permit ingress, DHCP requests only. Trusted ports can host a DHCP server or can be uplinked toward a DHCP server. If a rogue device on an untrusted port attempts to send DHCP response packet into the network, the port is disabled. From a DHCP snooping perspective, untrusted access ports should not send any DHCP server responses, such as DHCP offer, DHCP pack, or DHCP NAC. Configure IPv4 DHCP snooping. Enable DLS1 and DLS2 to trust DHCP relay information from ALS1 and ALS2 so that the DHCP server can respond to ALS1 and ALS2 trusted port requests. This is accomplished using the IP DHCP relay information trust all command. Okay, IP DHCP relay information trust all on DLS1 and also on DLS2. Okay, go to DLS1, enter Cisco enable class configure terminal IP DHCP relay information trust all, and the same command on DLS2. Enter Cisco enable class configure terminal. Enter. By default, switches that relay DHCP requests will insert option 82 information, which can be used for various management functions. When a switch receives a DHCP frame that has an option 82 information on an untrusted interface, the frame will be dropped. The IP DHCP relay information trust all command is one way to work around this default behavior. It is not necessary to enable DHCP snooping on the distribution layer switches, although this would allow DLS1 and DLS2 to trust ALS1 and ALS2 as relay agents. Configure ALS1 and ALS2 to trust DHCP information on the trunk ports only, and limit the rate that requests and receive it on the access ports. Configuring DHCP snooping on the access layer switches involves the following steps. Turn snooping on globally using the IP DHCP snooping command. Configure the trusted interfaces with the IP DHCP snooping trust commands. By default, all ports are considered untrusted unless statically configured to be trusted. Configure a DHCP request rate limit on the user access ports to limit the number of DHCP requests that are allowed per second. This is configured using the IP DHCP snooping limit rate. This command prevents DHCP starvation attacks by limiting the rate of DHCP requests on untrusted ports. Configure the VLANs that will be used DHCP snooping. In this scenario, DHCP snooping will be used on both the student and staff LANs. For example, on ALS1, enable globally IP DHCP snooping and go to interface range of interfaces 7 to 12. For example, IP DHCP snooping trust, then exit. Remember, these interfaces are not in use. Okay, are not in use on the ALS1 because are not in use on ALS1 because on ALS1 6 and 15 to 24 configured. Okay, but on the range in use 6 and 15 to 24, IP DHCP snooping limit rate to 20, then exit. Okay, remember the limit rate is 20. Okay, limit the number of DHCP requests that are allowed per second. And finally, implement DHCP snooping for VLAN 100 and 200. Same case on ALS2. Okay, go to ALS1, enter Cisco enable class configure terminal. IP DHCP is Snooping. Go to the range on ALS1. If I'm using gigabit 1.3 and 2.2 and 2.3, I will use gigabit 2.0 and 2.1. Interface range gigabit 2.0 and 2.1. And I'm sorry, 2.0 and 2.1. Okay. IP DHCP Snooping trust. Exit and go to the interface in use. Interface range gigabit 1.3 and gigabit 2.2 and 2.3. And IP DHCP Snooping with limit rate to 20 packets per second, 20 DHCP requests, 20 DHCP requests per second. Okay, limits. Okay, very nice. Then exit to global configuration mode and apply DHCP Snooping on VLAN 100 and 200. The same case on ALS2, enter Cisco enable class configure terminal. IP DHCP Snooping. The interface range is gigabit from 2.0 and 2.1 to 0 and 2.1. IP DHCP Snooping trust. Exit. And the interface range from gigabit 1.3 and gigabit 2.2 and 2.3. IP DHCP Snooping limit rate 20. Exit. IP DHCP Snooping VLAN 100 and 200. And verify. ALS1, for example, and show IP DHCP Snooping. Okay, show IP DHCP Snooping. Enabled VLAN 100, 200, operational and 100, 200. Option 82 is enabled. Option 82 on untrusted port is not allowed. Gigabit 1320 and 21. Gigabit 13 trusted no. Allow option no. Rate limit 20 packets per second. 20 and 21 trusted yes. Rate limit unlimited. Okay, so gigabit 20 and 21 are permitted. And gigabit 13 is not permitted for DHCP, but also is configured with a rate limit of a maximum of 20 packets per second. Also, gigabit 2.2 and 2.3 not permitted, not trusted ports, and rate limit configured. IPv4 DHCP snooping operation. To verify DHCP snooping is working, rerun the task conducted to observe DHCP operation without DHCP snooping configured. Ensure Wireshark is still running on host A. Issue the ipconfig renew command on host B. In this case, the DHCP discover should not be seen on host A. Okay, this is very interesting. Go to host A. Okay, this host A. Enter TCP dump interface Ethernet 1. Cisco. Okay, and these are HSRP messages, and go to host B, this host, and apply the on Windows is ipconfig renew, but on Linux is sudo DHC client on the Ethernet 1 interface. Enter Cisco, the password, and go to host A. And there are no DHCP messages. No DHCP requests. Okay, I think it's enough. Control-C to stop. Review. No DHCP messages. So that means DHCP snooping is working very well. Go to ALS1. Once validated, change ALS1 Fast Ethernet 6 back to VLAN 100 and make sure host A and host B have a valid static IP address assigned. For example, host A 100.1.1, default gateway 100.1, host B 200.1.1, default gateway 200.1. Okay, ALS1, configure terminal. In my case, it's gigabit 1.3 here on ALS1, not Fast Ethernet 6, interface gigabit 1.3. Switch port, access VLAN 100. And go to host A, enter and configure the IP address. In my case, 100.10. Subnet mask 24. Verify IP routes. Okay, know the default gateway and add the appropriate default gateway. 100.1. Okay, use this command, show sudo IP route at default via 100.1. And very nice. ifconfig host A 100.10 and go to host B ifconfig 200.10. Will DHCP replace VLAN to ingress access ports assigned to VLAN 200? No, the access ports assigned to VLAN 200 are untrusted for DHCP snooping. Only the DHCP requests can be sent out these ports, not replies. How many DHCP packets will be allowed on Fast Ethernet 16 per second? I think should be Fast Ethernet 6, okay, per second. It will be limited to 20 packets per second. Configure AAA. AAA stands for Authentication, Authorization, and Accounting. The authentication portion of AAA is concerned with the user being identified before being allowed access to the network. Authentication is configured by defining a list of methods for authentication and applying that list to specific interfaces. If lists are not defined, a default list is used. For this network, it has been decided that AAA will be used to validate users attempting to log in into the VTY lines or for our network devices. For this lab, the AAA server will be a radio server on host C 172.16.99.50. And remember, host C is the server, the DHCP server, connected to the LS1 Fast Ethernet 6 interface. There are many different radius servers alternatives, but for this, the program WinRadius will provide the radius function and host the username password database. Configure switches to use AAA to secure VTY line access. As it stands, all the switches should have a statically assigned password of Cisco the VTY line. This is not a scalable configuration. It requires a single now password and manual modification of each switch individual, as well as controlled dissemination of the single now password. Using centralized authentication is a much simpler method, where each user uses their own unique username and password. Configure PCC, the server, PCC, the server, with the 172.16.99.50 with a default gateway on 172.16.99.1. Ensure that PCC has connectivity to the gateway and all 4 switches. Okay, you need to configure the PC with an IP address on VLAN 99. The IP address of the AAA server will be 9950. The default gateway obviously ensure PCC has connectivity to the gateway and all 4 switches. But okay, so this is not critical for me because I don't have the radio server or AAA server on PCC. Okay, I will only configure the clients. But on all 4 switches, configure AAA. Okay. Enable AAA using AAA new model command. For example, on ALS1. Exit AAA new model. Configure a local username last ditch with a privilege level of 15 and password and this password. Okay, username last ditch privilege 15, password Cisco 123 and this character. Okay, this is the username and radio server, authentication port 1812, accounting port 1813, and shared key WinRadius. This is the password. Okay, radio server. You can use a name, any name. In this case, radius. Set the address on IPv4. Remember the address of the server 9950. The authentication port 1812. The accounting port 1813. Okay, this is the command. And the key, this is the password, win radius. This password is to authenticate with the server. Okay, so the server should be configured a client named ALS1, and on the server ALS1 client is configured to use this password. On the client ALS1 you are configured AAA username, and the server is this uses this IP address, this ports, and to authenticate with pserver, to authenticate ALS1 with the pserver, use winRadius password. Then exit. Now configure AAA authentication method. Call it remote control. You can use any name to use the radius server and to fall back to the local database. Okay, AAA authentication. Login. The name is remote-control. The group is first use the radius server. If you can find the radius server, use the local database. Finally, apply that method on VTY lines. Okay. AAA authentication login. The name remote control. The group. First of all, search the radius server for the username and password. But if the radius server is not present, use the local database, the local username configured on the switch. Now, on line VTY 0 to 15, apply that method, login authentication remote control exit. Okay. Configure winRadius. Okay. You need to go to Appendix A and download the software, install the winRadius software, configure the database. Okay, basically this is a Windows implementation, but I have a video with Linux implementation of this that is very interesting. Okay, and then you can verify the authentication. Finally, shut down unused ports and move them to a parking lot. As an added layer of security of our campus architecture, ensure that all unused ports are configured as static access ports. Shut down and move it away from VLAN 1 to an unused VLAN named parking lot. Verify that the ports are unused because applying this configuration to trunk ports will adversely affect layer 2 connectivity. Also add another protective measure by suspending the state of parking lot VLAN. Repeat the below configuration on all unused switch ports on all switches. I will do this only on ALS1, for example. The interface range of unused ports. Okay, in my case, I will choose gigabit 20 to 21. Interface range gigabit 20 to 21. Then apply the configuration switch port mode access and access VLAN 999. Okay, shut down the interfaces and verify show VLAN brief. Show VLAN brief shows the 999 parking lot. VLAN configure terminal VLAN 999 state suspend. Okay, but VLAN 999 is VTP LAN configuration not allowed when device is in client mode. So you can't apply the state suspend command. You need to suspend on DLS1. So DLS1 is the VTP server. Cisco enable class show VLAN brief. Okay, 999 active. Configure terminal VLAN 999 state suspend end. Okay, you need to apply the end or exit command to apply changes. Now verify show VLAN brief suspended. Go to ALS1 and show VLAN brief suspended. Okay, this is the security on this VLAN. Now save your final device configuration for use with the next lab. Okay, apply this on all other switches, but I'm doing only an ALS1 as an example.